We are going live. Yes, we are live now.
Allora, hello, I warmly welcome you to our 56th webinar by the Academy of Space Renaissance International. On this 5th of February, I'm really delighted that you have come to join us. We have people watching from Chicago, from France, from Holland. And my name is Sabine Heinz. I'm the person responsible for our webinar series and one of the vice presidents of SRI and also responsible for our art chapter. And our today's special guest is Alberto Cavallo. Hello and welcome,
Hello.
Alberto.
Hello.
And Alberto will talk about evolution and state of the art of launch systems. I also would like to welcome Adriano Ottino. He is also one of our vice presidents and former president and one of the founders of Space Renaissance International. Hello, Adriano.
Hello, Sabine and Alberto. Very welcome.
Alberto, before I give you the floor, I would like to introduce you to our audience. Give me a moment. Alberto Cavallo is an electrical engineer, graduated at Politecnico di Torino in 1985. He began his activity with designing electric systems and Fiat Engineering, the engineering and construction company of the Fiat Group, of course, and moving soon to control and automation systems in the same company. He was involved in all business areas of the company, which included revamping and new projects of car factories for the Fiat Group, as well as large infrastructures, power cogeneration plants for external clients. Among the projects of the time were the new Fiat factories in Melfi and Pratola Serra, the high-speed railways Torino-Milano and Bologna-Firenze, the district heating system of Torino Sud, south, and combined cycle power plants for several hundred megawatts in Italy and Brazil. Since Fiat Engineering was transferred from the Fiat Group to a new EPC group and then merged with a large EPC company in Milan, he has been involved in large oil and gas and petrochemical projects all over the world. Besides his professional activity, he has always taken part in several cultural activities. He was a member of the associations of alumni of the Liceo Classico Vittorio Alfieri of Turin, active in promoting humanistic culture as well as its connection to the technical and scientific area. He managed his own website, 3W Urinome Italy, also it's only in Italian, and about philosophy, science and politics and geopolitics. Due to this, he got in contact with Adriano Ottino and his technologies of Frontier, so TDF, then becoming one of the founding members of Space Renaissance International. Besides several papers in his professional area, he has written several articles for his own site, for TDF and SRI, co-authoring the book 3 Theses for the Space Renaissance with Adriano Ottino and Patrick Collins. He's currently member of the board of SRI. Yeah, Alberto, the stage is yours. I'm really curious to learn more about your topic.
Thank you very much, Sabine. Thank you all who are watching us. Tonight I want to talk about the development in space launchers. I have prepared the presentation for this that I'm starting to share now. And essentially, what is happening what is happening now in our new century. Space launches used to be, in the past, I hope that my presentation is appearing. In the last century, space launchers were just a single use, expendable. But if we want that humanity expands into space, space transport must become like any other kind of transport. We don't throw away an airplane or a car after each use. So what's happening is fundamental change. Now, expendable rockets are being replaced with reusable rockets. And this presentation explains what is the general situation of this evolution of from expendable rockets to reusable rockets as it happened until the end of the last year and the beginning of this new year. We start from the statistics of last year. In last year, 2023, we had a total of 222 orbital launches worldwide, of which we have to say that 91 were made with SpaceX Falcon 9 and 5 with Falcon Heavy. That means that SpaceX totaled almost 100 launches. They couldn't reach 100, but they went near. 9 more launches were made with Rocket Lab Electron. And this is another rocket, a third rocket, that is designed to be reusable. That means that in total, 105 launches over 221, that is 47.5%, were made with reusable rockets. And the most used launcher of 2023 was, of course, a reusable launcher, Falcon 9. So we start with the first part of this presentation. This first part is about reusable rockets that are already in use and widely. So they are essentially 3, the Falcon 9, the Falcon Heavy of SpaceX, and the Electron of Rocket Lab. Falcon 9 is the workhorse of SpaceX, and now it has overcome any possible limit, and the number of launches, the number of successes is so high and constantly increasing that it's even hard to say how many launches have happened till now. The numbers till last Saturday were 294 total launches, 252 landings, and 226 reflights, according to SpaceX website. I also wrote here the price per launch as it's written on the website, $67 million per launch. This is a price, not a real price the clients pay, and not, of course, the cost of a launch. This is a very indicative maximum cost. For sure, no actual client pays this cost. They pay for sure less. This shows how prices have gone down, and at least in the end, we don't know exactly what is the real cost of a Falcon 9 launch. They know, and they use it for their own initiatives, because many launches are linked to the famous Starlink system of SpaceX. This is a general presentation of Falcon 9. On the left, on one side, you see a representation of the rocket, and then the main data. The most interesting things, the size, like 70 meters high, 3.7 meters wide. What's interesting is the payload to low Earth orbit, that is most common mission. In reusable mode, it is 17,400 kilograms. It can reach 22,800 kilograms if it is used in expendable mode, but it's almost never used in that mode. Basically, it never happened. The engine type and the fuel and oxidizer are quite common, because the engine type is a liquid fuel gas generator engine. That is the most essential rocket engine, the basic rocket engine usable for orbital launchers. And also the fuel is kerosene, of course, rocket-grade kerosene used with the liquid oxygen. So essentially the choice of SpaceX was to stick with the most straightforward, simple solution to have the highest reliability. It's not as particularly advanced. It's just very much refined. The rocket is composed of 2 stages. The first stage, that is also called the booster, covers 2/3 about of the rocket, and it is the reusable part. It has 4 landing legs, and it's used to land. I'll explain later how. You can see here also how the tanks are arranged inside the rocket. The second stage, the black part is the interstage, the connecting the 2 stages. The second stage uses one of the same engines of the first stage, only modified in the nozzle to operate in the vacuum instead of operating inside the atmosphere. And it is expendable, the second stage. They tried to develop a reusable second stage, but they stopped this development since now they are developing the Starship, so it's not required to develop a reusable second stage. We can see how simple in the end this rocket is. The first stage, as I said, lands and re-lands propulsively. This is the big innovation of SpaceX, because previously we know that the main idea was using wings and landing on a runway. In fact, there were prototypes, but it is a long story, and I will skip here. Maybe if there is some question later, I'll explain something about the previous history of this kind of landing. Anyway, this kind of landing is the simplest possible and very easy with the rocket engine. Not so easy, but they developed very well it. And essentially, the booster may have 3 engine burns or just 2, depending on how it lands, because it can land near the launch pad, and this means that in this case it uses 3 burns of the main engine on the engines. The boost back burn that brings the rocket back towards the launch site. The entry burn that used to slow down in order to reduce the stress of the rocket when hitting the atmosphere, and finally the landing burn with only 1 engine. There is a very interesting point that I want to underscore here. When it lands, it uses 1 engine at the minimum thrust. But the minimum thrust of a single engine is more than the weight of the empty rocket that is landing, which means that the rocket shuts down exactly when the rocket engine shuts down exactly when the booster touches the land or touches the drone ship. And otherwise, it would again go back to and take off again, because it's too much powerful. But they had hundreds of successful landings like this way. So they make it look easy. Maybe it's not so much. Many landings happen on the autonomous space for drone ships simply because they don't have the fuel for the propulsion back to the launch site. In this case, they use a landing platform on the sea, autonomous, because there is no crew, because just for safety reasons. Now, first stages of Falcon 9 have been used up to 19 times. Initially, they foresaw 10 reuses for each one of the latest version, but now after gaining experience, they have reached 19 times, and they are now considering even up to 40 times. And they don't only recover the booster; they also recover the fairings. The 2 fairing halves that are I could go back. Okay. Going back to the rocket, it is the upper part of the rocket. No, sorry. The upper part of the rocket. I don't know if you see the arrow. This part is called the fairing. It's composed of 2 halves that separate after the stage separation, and they fall back. They splash down in the sea, and they are recovered too and reused. The second rocket of SpaceX is the powerful Falcon Heavy. Falcon Heavy is the most powerful launcher of SpaceX, but it's also the most powerful launcher already in operational service. Of course, there is a much more powerful launcher that is the Starship by SpaceX, but it is not yet in operational, is only under testing. The first stage of the Falcon Heavy is composed of 3 cores, and the 2 side cores that are called the side boosters are exactly the same as a Falcon 9 booster. And in fact, it happened several times that some boosters were used in both roles, as side boosters for the Falcon Heavy and as main boosters for Falcon 9. The central one is modified for structural reasons because it has to connect to the boosters. The 2 side boosters are recovered, while the central core is usually not recovered. They tried to recover the central boosters. They almost succeeded, but in the end, the only one that landed very well was then lost at sea, and in the end, no one was ever completely recovered. In the end, the numbers are very small for Falcon Heavy because the Falcon Heavy is very big. If we compare it, its length is the same because the central part, the central core is essentially much like the Falcon 9, and but it is 3 times the power. The payload is not 3 times, but almost. The engines, of course, are the same, but the engines of the first stage are 27. It is a big number. It never happened until now, during a launch of the Falcon Heavy, that one of those 27 engines did not work. It's very, very interesting because it's significant that such a large number of engines, they always work perfectly. The second stage is exactly the same second stage of the Falcon 9. Here I put the image of the 2 side boosters landing because it's very, very nice view to see 2 rockets that land at the same time, like a synchronized flight. And then I want to speak about a small rocket that is very interesting because the Rocket Lab Electron has been designed since the beginning to be reusable. It's true that they never used a booster till now. They only reused a single engine. But they have recovered, maybe this number is lower than truth, they recovered 9 of them, not 7, but anyway. They recovered the boosters, and they will try to launch one to reuse them in the future. This is a very small launcher. The payload to low Earth orbit is only 300 kilograms, so it's very, very small if you compare with the Falcon 9. It's very interesting anyway because technically is particular. The engines have electric pumps, not turbo pumps. This is very innovative, and of course it's only good for small rockets like this because essentially they need the batteries to feed the electric pumps. But for this kind of small rockets, it's a very, very, very elegant solution. Apart from this characteristic of the engines, the fuel is the same of the Falcon 9, and the oxidizer is the same. Of course, the rocket is much smaller. This rocket is composed of 2 stages plus the so-called kick stage. In fact, it's somehow 3 stages because the first stage and the second stage are much like those of the Falcon 9. Of course, smaller, much smaller. The kick stage has the function of relighting several times when to place the satellites in the correct orbit. While, for instance, in the Falcon 9, this is done by the second stage. In the case of the Electron, the second stage only performs the launch phase, and the kick stage is the one that brings every single satellite to the right place, because for every launch, several satellites may be launched. For instance, in the last launch, there were 4. They tried 2 ways of recovering the first stage. They don't use landing burns or boost back burns and so on. The the booster just goes down, slowing aerodynamically, and then it uses parachutes to slow down the descent. They tried at the beginning to catch it in midair with a specially equipped helicopter. But they never succeeded to completely recover a booster like this. They succeeded in catching it, but then it was lost. And then they decided to splash it down and recover from the sea. They have, till now, they have reflown just a single engine, but now they plan to refine the boosters. So we can see here the Electron booster floating on the sea. It lands with parachutes and then is recovered by a recovery ship. Of course, you can see how easily it floats, because of course a booster in this phase is essentially an empty tube. And it's composed of mostly of empty tanks, so it floats like a piece like a cork. So we have seen now the reusable launches that are already in operational commercial service. Now we go to the ones that are in advanced stage of development. That means at least some tests have been performed, or at least they have a predecessor in service. Starting, of course, with the SpaceX Starship. Then we have the future rocket of the Rocket Lab. It is the Neutron. We have the Relativity Space Terran with one flight test, and we have the Blue Origin New Glenn. And then we have several Chinese rockets. The Starship is the largest orbital rocket ever made. It has almost twice the power of the Saturn V that was used to go to the moon. And it is designed to go to the moon and go to Mars. They are looking to the near future. SpaceX plans to use the Starship to launch a new generation of Starlink satellites, larger and extended capabilities compared with the current Starlink satellites. You know, Starlink satellites are those satellites. There are already more than 4,000 or 5,000 in orbit that are used for fast internet connection, with a totally new concept, because they orbit on a low Earth orbit, so the distance to the ground is very small. Of course, they move very quickly, so there is a large number of satellites is needed, because your connection is switched over from one satellite to another. SpaceX Starship has been chosen as the landing system for the NASA Artemis program to return to the moon. And it will catch the astronauts in moon orbit, because the astronauts will be brought to moon orbit by the Orion spacecraft, by NASA, and then they will transfer to a Starship and use it to land on the moon. Then we have the Japanese billionaire Yusaku Maezawa that booked a complete Starship flight around the moon for himself and a selected crew of artists and celebrities, and several people, more or less common people, including the everyday astronaut, to fly around the moon. And another billionaire has done the same. So there are some interesting missions already planned before doing what Elon Musk would want to do is going to Mars. Some essential data, of course, the data are constantly changing because Starship is under development. So the main numbers are that the payload to low Earth orbit is 150,000 kilograms, 150 tons. That is more, of course, than a payload to LEO of the Saturn V. It has 33 Raptor engines in the booster stage, and then 3 + 3, and maybe they will increase in the future in the second stage. We are still talking about first stage and second stage, but the concepts are really a bit different. The first stage is a booster, of course, and essentially brings the launcher up to some height before that, before switching over in the separation of the second stage. The second stage is called the Starship proper, and it is a space vehicle on its own, because it's not composed of a second stage plus a capsule, for instance, because it is conceived as a spacecraft on its own, able to fly to the moon, to fly to Mars, or whatever. One word about the Raptor engines. The Raptor engines are the most advanced rocket engines ever made, because they are full flow, closed cycle, methane-powered rocket engines. Full flow means, it's very complicated to explain, just a few words about that. The full flow of both oxygen and methane go through the preburners. They have two preburners that run the turbines, that run the pumps, that run the main engine. This is extremely efficient, and it was tried in the past, but these are the first full flow engines that will reach orbit. When they do, they almost did, in fact, during the test flights. So I already described this. I think just to add that the super heavy booster does not need an entry burn, since it is made of stainless steel. It can survive high mechanical stress, and it is designed to land on the launch pad. This idea is about is the purpose of allowing a very quick turnaround and a very quick time to the next launch. In fact, it lands on the exactly on the launch pad, so it can be launched in hours. They are planned to do in the future, maybe to reach the possibility to launch again in hours. The Starship, the upper stage, is an integrated spacecraft, as I explained before, and it's very interesting how it re-enters atmosphere, because the entry maneuver was never tried before. It enters in a horizontal orientation, exposing a side. It has a thermal shield on the side. By the way, it's made of stainless steel, so it can survive very high temperatures more. So this thermal shield is not so critical as thermal shields of other kinds of spacecraft. It has 4 aerodynamic surfaces that are not wings. They are aerobrakes, essentially, and they are used just to control the descent. Essentially, it goes down like a skydiver before opening the parachute. Then it rotates, it lights up the engines, rotates to the vertical position, and lands propulsively the SpaceX way. It's not clear if it will be caught in midair by the arms of the launch tower, or it will be regain landing legs in the future. Maybe both possibilities will be there. And in the end, they already performed the landing on 5th of May 2021 with the prototype SN15. Which reached the 10 kilometers of altitude, performed an aerodynamic descent, flipped to vertical position, and landed on its provisional landing legs. Then we go to the orbital tests of Starship. The 2 tests were done. The first one was successful in clearing the tower and reaching max Q. Unfortunately, then control was lost, and it was necessary to to activate the self-destruction system. It's true that 3 engines refused to start from the beginning, and more engines failed. And then seems that this was due to a fire on board that burned the control cables of the engines. This test, anyway, was very successful, because several targets were reached, and it immediately Starship gained the record of being the most powerful rocket ever launched. The huge amount of data allowed engineers to repair, to fix all the failures, and then to be able to test again. This is the way, very much different from the way NASA traditionally did with rockets. You can look at the SLS, for instance. NASA made years of tests on the ground in order to have a first launch that is almost perfect. SpaceX immediately tries a launch, knowing that the probability of full success is low, and they learn by what happens. It seems more costly, but in fact, it showed that it is less costly. It seems strange, but it is like this. The second launch was almost a full success because in November last year, first of all, during the first test, the launch pad was heavily damaged, and this caused some environmental issues too, because pieces of concrete were launched to a lot, several kilometers away. So they had to change completely the structure of the launch pad by adding a deflection system and a water deluge system in order to protect the launch pad from the power of the 33 engines. This time, the booster worked perfectly until stage separation. Stage separation was performed with the hot staging technique. That means that the second stage ignites before the separation. There are holes in the sides of the interstage, allowing the exhaust gases to flow out. And this is the maneuver that is new for American rockets, but it's very old for Russians, because if you look at any Soyuz rocket, it's made exactly like this. The booster, after the separation, exploded, and this explosion was probably due to the change from a negative to positive acceleration that caused the remaining fuel to move violently back and forth inside the rocket and causing damages that brought to the explosion. Then the Starship almost reached the second stage, almost reached orbital velocity. Elon Musk declared that the explosion was due to oxygen venting required since no payload was present. So since there was no payload, there was a lot of fuel and oxidizer left. They had to vent it out, and unfortunately, while venting out the oxygen, they caused this explosion. But in space, that happened in space because it was almost near the orbital velocity. This test was a great success because, and in fact, they are almost sure that they will reach orbit in the third test, and they are even planning to perform more tests during the same flight. So Starship is almost ready, but there are many other reusable rockets in development. For instance, we talked before about Rocket Lab. Rocket Lab is developing this significant rocket that is called the Neutron. You know, they call them from elementary particles. Electron is very small, the neutron is big. This new rocket is another rocket with reusable first stage and expendable second stage, but with many innovations. Payload to LEO is 13,000 kilograms, somehow less than the Falcon 9, not so much less. The engine type is more advanced than the engines of the Falcon 9 because it is an oxidizer-rich closed cycle, so it's quite advanced. It's like most Russian engines, by the way. And it uses methane, like the Starship. Methane is the fuel choice for most of the new rockets because it burns cleaner. And this is very interesting for reusing the engines. And there are other reasons. It allows higher efficiency, and it's not so bad to manage as the hydrogen. What's interesting about the Neutron is that the second stage is contained inside the first stage. Then the first stage opens a mouth and releases the second stage. This allows the first stage, the booster, to recover a complete aerodynamic structure that maybe gives good performance during re-entry. Then another new entry in the field of rocket launchers is Relativity Space, another American launching company. They are developing a fully reusable, that what had to be a fully reusable, they have changed somehow their mind. Medium-sized orbital launcher in the same class of the Falcon 9 and the Neutron. What's interesting is that the Terran rocket is almost entirely 3D printed. They have made the largest 3D printer in the world to 3D print the entire rocket, not just the engines or some details. Also SpaceX 3D prints several parts, but not the whole rocket. What they have done now is testing a smaller prototype, not reusable, just a test item. It was called Terran 1. It was tested last year with good success. It did not reach orbit, but it cleared the tower. It reached the stage separation. You can see here the main data about the Terran 1. Its payload to LEO is 1,250 kilograms. This is not so interesting in the end because they will never use this rocket to launch anything. They have just made one test. The engine type is the simplest possible, but it uses methane, not kerosene. And of course, this is a small rocket. You can see that it looks like the Falcon 9 very much, but it is much smaller. During its only flight, it reached max Q, it reached stage separation, but the second stage refused to ignite, so that's why it did not reach orbit. In the end, it was a good success for the booster, and they decided after this only test flight to develop immediately the Terran R, that is the real reusable bigger rocket, but changing its design. Essentially, the Terran R, you can see here, is essentially like almost the same performance of the Falcon 9, almost the same payload to LEO. It has 13 engines instead of 9. It uses methane instead of rocket RP1 rocket fuel that is kerosene. Essentially, it works like a Falcon 9. Previously, they had considered to recover the second stage. It was looking more like a small Starship, but they have renounced to do this. And now they expect to fly in 2026. And this is another American rocket. Then Blue Origin, of course. Blue Origin is the other big company that is developing reusable rockets in the US. They are already flying, have been flying the New Shepard suborbital rocket for a long time. It is fully reusable, but it is a suborbital rocket. It just reaches 100 kilometers of level at 0 speed, not the orbital speed. Between orbital speed and 0 speed, there is a big difference. That's why the rocket is much smaller. And of course, every part of the mission is much easier. Anyway, they are fully managing the re-entry and the recovery of the rocket. And then they are developing an orbital launcher called New Glenn. They are using the name of American astronauts. Shepard was the first American astronaut in suborbital flight, and John Glenn, of course, was the first American astronaut reaching orbit. This rocket is big, much bigger than the others. You can see the height is 98 meters compared with 70 meters of Falcon 9. The payload to low Earth orbit is 45,000 kilograms, so it is basically 2/3 of the payload of the Falcon Heavy. So it's a very big rocket, about twice the payload of the Falcon 9. It has 7 engines, the P4 engines that are oxidizer-rich closed cycle and use methane. And they have already flown, as I'll explain. It's designed for performance. It's not much less than the Falcon Heavy. They are very secretive, but we know now that they are quite advanced now in developing the rocket. We don't know where it will land, but they used to have they had a ship that was modified as a landing ship, and it was bigger than the drone ships of SpaceX because the New Glenn is big. Because you have to consider that it has just one booster that is in where the Falcon Heavy has 3. So this is a very big booster. So you need a very big ship. But they have scrapped the ship, so probably they will land the booster on land. Launch dates are not known, but they have a factory near the Kennedy Space Center where they are building the rocket. And I'll show something after. The BE-4 engine has been already used in space, and it can be said that the BE-4 engine is fully tested because the new Vulcan launcher by ULA uses this engine, replacing the Russian RD-180 engines that had to be abandoned for political reasons. And the first launch happened on the 8th of January on the Vulcan Centaur, that is a rocket by the ULA, but using the Blue Origin engine. So this engine is fully tested. It is, that launch was fully successful, and that engine can be declared as to be completely ready to reach orbit. This is a picture of the factory where you can see several pieces of the New Glenn. So we can. This picture is not so recent, but we can say that they are building the rocket. So it's likely that that we see the first flight of the New Glenn in this year, even if they have not declared the precise date. Then we move away from the United States and we move to China, because we have several different companies developing reusable rockets in the US, but we also have several in China. And just the order is not so significant. The first one is iSpace, or Interstellar Glory. They announced the Hyperbola 3 with the capability of 13 tons to low Earth orbit, methane, liquid oxygen, reusable first stage, first flight in 2025, first recovery in 2026. They have already completed 2 hop tests last year in November and December with the prototype. You can see of course, it looks slightly different. It has one thing I did not say about the SpaceX Falcon 9 is that these grid fins that are used to guide the booster during re-entry, or when it has already re-entered the atmosphere, they can be used to aerodynamically steer the booster. And they have copied not say they have copied, but the idea is the same. Here we see also an image of another Chinese startup, Landspace, with the Zhuque 3 stainless steel 12-ton low Earth orbit, 12-ton to low Earth orbit liquid methane, liquid oxygen rocket. First flight in 2025, like the other one. They have already conducted hop tests. You can see one. These hop tests are like the ones that SpaceX conducted around 2013 with the Grasshopper. This is a reduced specimen of the launcher, of the booster, with only one engine, just to test the takeoff, maneuvers in flight, and landing of the rocket. They have already done. And then there are at least 3 other Chinese companies in some stage of development: Galactic Energy, Deep Blue Aerospace, and Space Pioneer. Maybe it's not so relevant to go into details because we don't have many details about this rocket. But we have reached the number of 5 different Chinese companies developing rockets. These are private Chinese companies. Then the state-owned Chinese company that currently is the second most important launching company in the world, because besides the American launches that are mostly made with the SpaceX, China is the second nation in number of launches to orbit, all performed by the state-owned company. And they are saying they are developing reusable rockets too, but we only know that they already have a reusable space plane, which can compare with the American X-37. Of course, we just know that they have it. It's more or less like a small space shuttle. And also about the American one, we don't know very much because they never say what they actually do with that objects. Anyway, they also have this. They say that they are working on a full flow 200-ton metal ox engine that is another engine like the SpaceX Raptor. Then, third part, some conceptual phase reusable launchers. These are just concepts, not yet reaching any kind of actual development in hardware. The first, of course, the other launching company of the US, the ULA, that was the most important launch company and the only one, because it is the merger of Lockheed Martin launchers and with Boeing. They have a concept for using not the complete booster, but only the engine pack, detaching it from the booster, having it land with a specific thing that is this aerodynamic shield, inflatable aerodynamic shield, to be inflated and used for re-entry, followed then by parachutes, and then to be recovered at sea. That is recovering just the engine pack. This is just a concept. They're not. I don't know if they are really trying to do something like this, and if this can be pursued, or if it is the case of pursuing like something like this, since all the others are developing complete recoverable boosters. So anyway, this is a concept that was developed. The Ariane group, of course, we go to Europe now. Europe now only has expendable rockets, and basically the Ariane group is the only group in Europe developing launchers for real till now. They announced 2 years ago that they are developing SUSI, the Smart Upper Stage for Innovative Exploration. That is a reusable upper stage. The concept is that conceptually it can be compared with the Starship. It's much smaller, and it is designed to re-enter aerodynamically and so on. And they are developing it, and their intention is to launch this kind of space vehicle on top of an expendable rocket the first times. And then when they have a reusable booster, then they'll have something like the Starship, a smaller one. They say that they are developing, this was announced last year in the end, that the first hop tests of their own first stage booster will happen in 2024. Anyway, what they are developing now is the Ariane 6, that is a fully expendable rocket. Anyway, maybe this year we will see a European Grasshopper. We hope so. And then I close this with another very, very much interesting launcher that is just a concept for now, the Skylon, because this is another revolution if they can make it. Because this is a single stage orbit space plane, taking off from a runway and landing on a runway like an airplane fully. Flying to orbit and back without any stages, without anything, and using the same engines to take off as a plane and then fly into space. Payload to low Earth orbit should be 15 tons in the same order of the Falcon 9. And you can see from the image, it is like a plane, at the beginning. How can it do something like this? Thanks to the Sabre engine, synergetic air-breathing rocket engine, a revolutionary engine never tried before. This engine is both a turbojet and a rocket. During the first phase of flight, it works like a jet engine of a plane. It has a compressor taking external air and compressing it and sending it to the burning chamber. And then it uses this situation until Mach 5 and 26 kilometers of altitude using atmospheric air plus burning hydrogen. So it's not needed to bring more oxygen on board. Oxygen is taken from the atmosphere. Of course, taking air at this velocity means that the temperature of inlet air is very high. And since there is a compressor, it's not a ramjet, it needs to cool down this air. And it has an extremely interesting inlet air cooler, taking the air from 1000 degrees centigrade and bringing it to ambient temperature. This component has been already tested because they are making this engine piece by piece. The first thing they did is the intercool, this inlet air cooler. They tested it, of course, in a testing site. And then after that, they tested the pre-burner. So they have two important pieces of this engine. They are going on with the financing, partly private, partly by the UK government and partly by ESA. The Skylon program is not financed, and then if you go to the REL website, you don't find it anymore. But because they are concentrating on the engine. In the end, this engine could be used also by other launches, or even can be used as a hypersonic engine for airplanes, for hypersonic planes. They also planning to do like this. So, just for the conclusion, just for citing the other two very important spacefaring nations, India and Russia, because of course Russia is the first spacefaring nation in history. It is a number of launches that is huge, and they say they are developing a reusable launcher too, but I have no images, no plans from them. They say it is somehow smaller than the Falcon 9. India is very famous because the ISRO, the Indian Space Agency, is very famous for making very cheap expendable rockets that are very effective. So they can manage low-cost launches with expendable rockets, and they announced a very ambitious plan for the next years to develop also reusable launchers. Just an announcement. Till now, we don't have any hardware to be shown. So this is the conclusion. Just showing a launch of the Falcon Heavy, just to conclude in the best way. I thank you all, and I'm ready to take questions, and there are maybe some other things that we may show tonight. Anyway, thank you all. I close here the main part of my presentation.
Thank you so much, Alberto, for this interesting lecture. It was really, I kept glued. Yeah, it was a nice summary, and I have some questions from the chat. And I wanted to mention that we have people watching also from Chicago, I mentioned, I guess, Dublin, Ireland, from Denmark, Gert-Jan Fass, I like your photos. And here has also some questions. The first one you answered already. The first question was, if there are any plans, Arianespace ESA develops a reusable rocket in nearby future. You answered this already. And the other question is, why methane wasn't used as rocket propellant before?
Interesting question. In fact, if we go back, no, several different fuels were used historically for space launches. Because one possibility is to use the hypergolic fuel. That means that fuel and oxidizer just start burning by contact. No, they don't need an igniter and so on. But in the end, the most significant fuels used traditionally are either hydrogen or kerosene. Why hydrogen and why kerosene? Hydrogen is the most efficient fuel because due to the fact that the efficiency of a rocket engine is linked to the velocity of the exhaust. And with hydrogen, you can reach the highest velocity because hydrogen has the smallest molecule. This is essentially the reason. Hydrogen has downsides, of course, because liquid hydrogen is at very low, requires very low temperatures. And even in liquid phase, hydrogen takes a lot of space. Also, hydrogen is very difficult to manage if you want to relight your engine and if you want to preserve hydrogen also in space for some time. One of the reasons why hydrogen is not used in Starship, for instance, it is that it is not advisable to use hydrogen to go to Mars. Because if you have to bring your fuel for 6 months of flight, hydrogen will cause big issues. On the other side, kerosene is simply very, very convenient. It's very easy to manage. It's liquid. It is simple. It doesn't give so much efficiency, but it's easy. It's very easily available and it's cheap. But of course, the efficiency is lower, and another drawback of kerosene is the fact that it produces a lot of soot when burning. It means that it causes problems may cause problems in engine components and also for reusable rockets. It's being used because the Falcon 9 uses kerosene. But it's not so, it's better to use some cleaner product. Methane was not used probably because they always went to the extremes. They used the kerosene because it's cheap, is easily available, easy to manage. Or hydrogen because it's the most efficient, is the best from any point of view, it's clean, it's lightweight and so on, but it takes a lot of space. Methane is a compromise. It's a compromise because it's more efficient than kerosene, less efficient than hydrogen, but liquid methane can be used, requires higher temperature than hydrogen, so it's easier to keep it on board even for a long time. So they moved to methane now, essentially most new rockets. I think these are the main reasons. Anyway, methane was also difficult to manage from other points of view because, of course, but the difficulties of the methane are less than the difficulties of hydrogen from the point of view of management on board. So in the end, it's just a compromise between the efficiency of hydrogen and the ease of use of kerosene. And another reason is that it can be produced, for instance, on Mars.
This was my question, exactly. This is what I wanted to ask you.
Yes, because Elon Musk wants to produce methane on Mars. And how? Because essentially on Mars there is water and there is carbon dioxide. In the atmosphere, carbon dioxide, and in the ground of Mars there is water. You take hydrogen from water, and with the CO2 you can produce methane. Again, it's more convenient to use methane instead of hydrogen for the reasons I said before: smaller tanks and easier management and so on. So in the end, methane is what is being chosen by most of the new rockets.
Yeah.
I hope that I explained more.
Yeah, thank you. Yeah, fully answered, I guess. And my question was also, I think it was also a reason could be because yeah, the production on Mars, the propellant production on Mars. And this question was from Michael Basco from Dublin. And now I have another one from Gertjan Fass. Also an interesting questions. What about Japanese JAXA? Are they have any reusable plans?
I don't know about the plans of JAXA.
Okay.
JAXA is concentrated on spacecraft, as far as I know. They are concentrated on making spacecraft and not launchers.
Okay.
So they are mostly they are. I have no information about their own launchers. They rely on American launchers now. You know, they participate to the ISS, and all launches are made either by SpaceX or by other companies. By the way, currently only SpaceX is launching from the American side to the ISS, both crew and not crew. Of course, this presentation was about the launchers. I didn't speak about the spacecraft. You would need 2 or 3 more presentations
Yeah,
to
but
talk
really,
about
really
the
interesting.
spacecraft.
There's another question, also from Michael Basco. Do you consider all solid rocket Gravity 1 rocket advanced or dead end, or a dead end?
In my opinion, my personal opinion, is that the solid rockets are a dead end. Because using solid rockets is not the best way to make a reusable rocket. Because it's easy to understand. Think of, do you know about anything like putting a solid fuel inside the rocket? It was done because the two boosters, the two side boosters of the space shuttle were solid rockets, and they were reusable. But reusing solid rockets is very complicated, while reusing liquid fuel rockets may become extremely easy. What SpaceX is planning is that the booster of the Starship lands on the launch pad, refueled, and fly again in few hours. You could never reach such a result with a solid rocket. It's impossible. With liquid fuel, you can do that. With the solid fuel, you cannot. And then, of course, we see. I didn't speak about Virgin Galactic because it's not an orbital launcher; it's just a suborbital launcher. So, I don't think it is. It can be scaled up to a big launcher. It's not. It is a dead end. Yes, in my opinion, this kind of rockets are a dead end.
And Chinese? How about Chinese projects?
I spoke about 5 different Chinese projects.
Yes.
By the way, I can show something more because I can also share some of the sources that I used to show some website where you can take information about it. I will share
Oh, this
the
is
screen
nice.
again.
Yes.
Okay, share the screen. I hope you can see my screen.
Yes. Yes, you can see it.
Okay. So this, for instance, is China's land space. This image is the one that I put in my presentation. You can see land space. They have already performed the hop tests. If we go to, for instance, okay, and this is iSpace. I also talked about iSpace.
Yes.
They also have a prototype of the same kind.
Yes.
You can see here it takes off from one position and lands on the other one. Exactly the same kind of tests that SpaceX performed with the Grasshopper. So the Chinese have already done. So they are at least 1 year more advanced than Ariane, if Ariane can keep the time they have said. And Chinese, essentially, they have already performed propulsive landings. So, and other things that like this is okay. You have seen this, and in this article of Space News, you can find maybe we will put in the future the links to these articles. In this article, it explained all the story of the Chinese reusable rockets. There are several articles like this. If you go to the Space News and so on, you can find easily. If you just Google up Chinese reusable rocket, you can find several articles about this. They are not so secretive in the end. They are showing this. So the Chinese are doing a good advancement in, and as I explained, there are several Chinese companies, and they are all private companies, not state-owned, all competing. So China is applying fully the idea of a private market for the launchers. So they are embracing the revolution of new space.
I have another question. I have heard this that North Korea is also working on a space program. Do you know something about it? You are smiling. I was smiling a little bit too, but we never should underestimate what other
No, I'm
countries
not
are doing.
underestimating. North Korea, they have, like several other nations, not as far as I know, not reusable. I was concentrating on reusable. If a presentation for non-reusable rockets would be much longer, because there are so many different kinds, and all these new countries entering space launches, they begin with the expendable rockets, of course. So there's no reason why North Korea could not make something.
Yes, we
But
don't know.
for sure, they are able. Unfortunately, they are able to make military rockets, and from a military rocket going to an orbital rocket is not so difficult. It was something that Werner von Braun did 70 years ago.
Here's Walter Hammond from Orlando, Florida, USA. And he's very interested. He is teaching aerospace engineering at the University of Central California, Florida, sorry, and has subscribed to our channel. And I'm suggesting, because the topic is so interesting, maybe we can do a workshop or a conference, one-day conference online. Are you interested, Alberto?
Frankly speaking, I'm not an expert on the. I'm just.
Yes, but in organizing something for our academy, so then you can put your email in the chat, and
yes, just we can take some initiative about that, of course. Yes.
Yes, this would be good. Adriano, you can put it in the chat.
I was writing in the chat right now.
You can put the Space Renaissance address.
Okay. Here are more questions for you. What about refueling in space with SpaceX plans? Also, what SpaceX plans do exist? But refueling.
It's very, very important, because of course I was concentrating on the launch phase. Refueling in space is necessary for Starship to reach the moon or to reach Mars, because essentially it burns up almost all the fuel for reaching orbit. Then the Starship must refuel in orbit, so it means that other starships must take off and bring the fuel to orbit. What SpaceX is planning is to have a space depot for fuel. So Starship can take the fuel from this on-orbit depot, refuel, and go on with its traveling to the moon or traveling to Mars. Traveling to the, by the way, since traveling to the moon is required to be the landing system for the Artemis program, and it will be done. And in fact, they are already planning space refueling tests not far from now. I think in the near future we will see something. They are planning, I think they are planning a test inside the same vehicle, transferring fuel from a tank to another inside the Starship as a first test. And maybe they can do this in the third test flight of the Starship. Then in the future, we will see two Starships exchanging fuel in space. This must happen soon, because they have to do this for the Artemis program.
But I think it is possible, because you can do it with airplanes. Okay, in space it is a little bit different.
Yes, the main issue in space is that you don't having no gravity. Because
yes, I know.
with airplanes it's easier. It's not easier. Okay,
yeah.
Maybe space is easier from a certain point of view, because you can get near, you have no, for instance, in air you are flying and you have atmospheric conditions. It's not so, it's tricky. But in space, what is tricky is that you have no gravity.
Yes.
So the fuel doesn't stay where it should be. You have to pump fuel from one tank to another tank, but the fuel
in space
inside the tank.
Yes.
So you need to control how the fuel behaves.
Adriano, before I give you the floor, there's another question in the chat. How realistic are SpaceX plans to use Starship for Earth-to-Earth transportations of passengers and cargo?
I think they are realistic. Of course, there are some points that have to be, frankly speaking, till now, we can say Starship has been designed to carry crew and cargo. Of course, it will start carrying cargo. Then we will have a crewed Starship for landing on the moon. It will not bring the crew from the Earth. It will the crew will transfer from an Orion to the Starship in moon orbit. This is something much different from the old Apollo times, because the Starship will reach the moon. The astronauts will reach the moon on another capsule. They will meet in moon orbit, transfer to the Starship, and use the Starship to land on the moon. And this will be the first crewed flights of the Starship. Then Starship is designed to be used to launch people in orbit and to Mars and back. So, of course, I don't know much about this part of all the systems for the crew and so on, because now what we only see the Starship as a pure vehicle for launching, and not we are not seeing all the systems that are needed to have a crew. Of course, the life support facilities on board and so on. We are not seeing this on the current version of the Starship, that is just a test version.
Yes. Adriano.
Yes.
You may ask your question.
Yes, I have a couple of questions. This first one is a general consideration. I think that Elon Musk has completely changed the market, the space market. He came on Earth like an extraterrestrial, I think, because the rest of the world was not ready to that. And the proof of that is that after 10 years that we have reusable rockets going up and down, we have first timid competitors that are 10 years later with their technological development. It is like if the rest of the world didn't believe in this revolution. But now the revolution is here. And everybody is understanding that they will be out of the market if they don't try to catch. even if they are late. So my first question is, from the anthropological point of view, what do you think? Why there is such a distance between the one who was called the Iron Man, no? Elon Musk, and the rest of the space industry? The space industry is astonished. The Ariane Group is just realizing now that they have to do something, because until yesterday they were saying reusability, no, we don't need it. No, it costs too much and it's not so efficient, etc. So something to be better understood. Maybe it is because Elon Musk is a visionary, he has a vision, and he wants to, and the rest of the industry is not the same. Probably this is probably another explanation. Okay, this was the first question. The second question is that while you were doing this research for this beautiful presentation and very informative and so on, did you catch some information about the third test flight of the Starship? I think this is the thing that we are waiting very much for, because we definitely hope that in 2024 we can go reusably in orbit and come back, and that would be a fantastic step to start civilian space development. Therefore, and now seems that they are waiting for the FAA permission another time. And so I think that this time the investigation will be easier than before, because in the second test they destroyed the launch pad, and it was no, in the first one they destroyed the launch pad and so on. In the second one they had problematic explosion and still near Earth, however, the launch pad was in good shape after the launch, and they almost reached orbit. Therefore, I think that this time the investigation should be easier. Maybe we hope so. And okay, second question is: do you have? Can you have will they really success to make the testing during February? That is what we are reading, that they are doing the third launch in February. Okay, this one.
Okay, first the first one. Yes, I agree with you. The space industry did not believe that it was possible to have a reusable rocket and have it the way Elon Musk did, because they were all most of American aerospace engineers were concentrated on the idea of winged systems like the space shuttle. If you consider the first design of the space shuttle, considered a whole winged system also for the booster.
Yes.
They were always thinking, oh, we can take off maybe like a rocket and land like a plane, or maybe even take off like a plane. And then the space shuttle showed that reusable, because the space shuttle was designed to be reusable.
In the first version, yes.
And even the real space shuttle that flew several more than 100 times. So in the end, a lot of flights. But in the end, if you consider
not fully reusable, because
no, but of the space shuttle, the orbiter was reusable, and the side boosters were reusable. Only the main tank was not reusable.
Mm-hmm.
Only the main tank. The engines were reusable.
Yes.
So the engines were all reusable, because the engines of the orbiter and the engines of the side boosters. But the cost to orbit of the space shuttle was higher than the cost of the older rockets.
Yes.
Because they did it wrong. And then comes Elon Musk, but why do we use wings? We have the rocket engines. We can land vertically. But it was not even new, because in the end, this idea is old. because there was the DCX. The DCX was a prototype made in the early 1990s that was designed for fully reusability with vertical landing.
Mm-hmm.
This idea was already there, and they had already tests about this. McDonnell Douglas did it. Then it was abandoned because NASA wanted a system that landed on a runway. And they preferred the famous Lockheed Venture Star. The famous Lockheed Venture Star that was abandoned because it couldn't be made. Because it included so many innovations that it was impossible to make. While the idea of Elon Musk, like when we also spoke before, Elon Musk, if you consider that the rocket engine that the Falcon 9 uses is a very simple rocket engine. They developed in-house. It's a completely new engine. They didn't take an existing engine, but it's a very simple engine. It's the simplest kind of orbital engine that is normally used. They use the single type of engine for both the first stage and the second stage. And if you look at the Falcon 9, it's made to be as simple as possible.
Yeah, sure. Yeah.
This is a concept that all this was not believed by the traditional aerospace industry and also by some political desires, not all, because in the end, Elon Musk had the support of some American institutions since the beginning.
Sure.
For instance, DARPA, the development agency of the Department of Defense, they put a lot of money into SpaceX at the beginning because they did believe in this, but only a few people did believe. Most of since also we spoke with the important persons of Europeans, in Europe, no one absolutely believed that it was possible. And Ariane was, as you said, Ariane was caught by surprise by what happened. Now they are trying to recover, but they are behind the Chinese. Chinese are more advanced.
Of course, yes, because Chinese are more pragmatic.
Yes.
The Chinese, look at what the Chinese did.
Yeah.
They began with the Russian material. They took the technology, the Russian technology, and till now they used mostly improved Russian technology. Then they are moving, jumping a complete phase of development. They are moving to the latest American technology.
Yeah.
Jumping the previous American technology, jumping directly from the Soviet era technology to SpaceX technology, like you could say. So they are very dynamic.
Okay, it's a complex situation, of course. Yeah.
But
we have attended to an let me say an exceptional 10 years from 2015 to now. It was an incredible time, I think. Something that can be compared to some other epochal.
In space, the 60s of last century, but in 10 years, we went from the first man in space to the first man on the moon. In 10 years. In less than 10 years.
Yes.
From 1961 to 1969, we went from the first man in orbit to the first man on the moon.
Yeah.
From 61 to 69. And then we were stuck in low Earth orbit.
That was the birth of exploration, the birth of exploration. But now these 10 years are the birth of civilian space development.
Yes.
Space settlement, yes. And let's see if it go.
Yes.
If the wars will not suffocate everything. Let's hope so. Good.
Yes.
Anything? One other thing.
Yeah. What about the next test flight?
The next test flight. I think they are almost ready. I think probably they have to wait for sure for the permit. They are almost ready, and we'll see. I don't know if they will launch in 1 month or 2 months, but no more than 2. No more than 2 months, I think.
Okay. Let's check it. In 2 months, we will be here.
This is my own forecast.
Okay, good.
Okay. Walter Hammond is saying China has a very robust launch vehicle development program. So, but maybe you'll get in touch. Also, he has our email address, and he will get in touch with you. I think it will be a good connection. Alberto, thank you so much for your interesting lecture and for the really fulfilling answers. They were really, fulfilling and understandable. Also, I really enjoyed your lecture and the questions. And thank you for being with us. Thank you to the audience for being with us, for listening all this time. And I would like to mention our next webinar. It will take place on the 19th of February, but this time at 7 p.m. So take care. It's a little bit earlier, 2 hours earlier. And we have as guest Giulio Prisco, and he will talk about space expansion, cultural considerations, long-term perspectives, and spiritual implications. So we are looking forward to this. And Alberto, thank you again for being with us for this interesting lecture. And I will have you again this year for another lecture. Then you can talk about the other rockets.
Thank you, Sabine. Thank you, Adriano. And thanks very much. Thanks to all our audience today.
Okay. Also, I wish you all a nice evening and goodbye. And Adriano, you wanted to say that everyone can join us and support us because we are working voluntary.
No, I have a very good news that Walter Hammond just wrote that he will join SRI.
Yes.
And I'm very happy of that. Thank you very much, Walter. And any other that want to join will be very, very welcome. We have many activities in the Space Analysis Academy, in our committees. So we have almost finished. I think it will be delivered in a few days, an heavy position paper where we say what SRI thinks about the K factors, critical issues before 2030. We had a very big discussion about space law, connected to ethics, connected to space philosophy, etc. It was a very profound discussion, and I hope that we were able to represent our position in the best way. And we are working on space habitats, on rotating space habitats concepts, of course, and not projects. And we are working we are organizing a workshop for September by our Young Generation Committee. That is a context for young researchers and students to make a statement of work for a Lagrange rotating infrastructure, for a small one, of course, but what we can think it could be developed. So it will be a context. There will be winners. The winners will have a scholarship to participate to the International Astronautical Federation Congress in 2025. And so we have many activities, very much more than what you can see on our socials, because we are, unfortunately, we are working a lot, but very few of the results are going outside. But yeah, we will try also to represent more of what we are doing and to allow many more people to join and work with us. So everybody who wants to join is very welcome. And yes, of course.
Yes. Everybody is welcome to join us and to help us and to support us. And we have a lot of activities. We also are working now for the IAC meeting in Milan, IAC Congress in Milan in October this year as well. Yeah. Okay. Thank you so much. And I hope to see you in 2 weeks again for our next lecture. And Alberto, again, thank you for joining us, for giving us this interesting lecture. And to our audience and you, I wish all of you a nice evening and hope to see you in 2 weeks. Okay, ad astra.